Problem number 6 is kind of like problem number 5 on the spring 2015 exam. It says indicate the best method and or identities and or trig integrals used for evaluating the integral. And it gives you tan cubed of ln of x over x dx. So again, if we look at the different options that we have in this case, I see that most of them are u substitution, and the only other one would be integration by parts and then u substitution. So let's try and apply a u substitution first, and maybe we can eliminate letter A right away. So the only thing I notice is that there is an ln of x and a 1 over x dx. So what I can do is I can say u equals ln of x and du equals 1 over x dx. So that substitution actually works out really well. And I can go ahead and rewrite the integral as tan cubed of u du. So u substitution is the right way to go. So letter A is kind of eliminated right away. So if I go ahead and write out A, B, C, D, E again, A is pretty much gone already. Now we're kind of left with a few other options. So letter C says that u sub and integral of secant squared d theta. Well, I don't see just an integral of secant squared d theta anywhere. I don't see a secant squared. So letter C looks like it would require some sort of intermediary step somewhere else for it to be correct. And in that case, this just isn't true because we have a tangent cubed, not a secant squared term. So now, by looking at the rest of them, they all look like they involve tan squared theta plus 1 equals secant squared theta, which is the trig identity that we know. So if I go ahead and write 1 plus tan squared u equals secant squared u, I have a tan cubed here, so I can potentially convert one of these terms into secant squared u minus 1. Now, will that do me any good? I'm not sure, but that's the only way I can really use this identity, and according to the answers, tan squared u has to be used somewhere, or tan squared u plus 1 equals secant squared u has to be used somewhere. So if I go ahead and plug in for one of these tangents, because I'll have a tan u times tan squared u, I can plug in for this one right here. That gets me secant squared u minus 1 times tangent of u du. Okay, good. Now, if I go ahead and distribute these terms out, I'm looking for which one of those integrals fits the bill. So in this case, if I look at letter D has a secant cubed theta, but according to this, we have now converted it into secant squared minus 1. So that one can't be correct either. I'm going to go ahead and cross out letter D. So we're left with B and E once more. B says that I have to have a secant and a secant cubed, and E says that I have to have a tangent and a tangent times a secant squared. So if I distribute this out, I end up with two integrals, because they're separated by a minus sign. One of them is tan u secant squared u, and the other one is minus tan of u. Both of which can be solved. This one is just a u substitution. This one has a definition. The integral of tangent is either the positive natural log of secant or the negative natural log of cosine. But it does have a solution regardless. So these can now be solved. And looking at the answers, this fits letter E because letter E says that after applying this substitution, we end up with two integrals, tangent times secant squared and tangent. So letter E is the correct answer in this case. That's what our integral would look like for number 6.
The Teaching Center, UF's Learning Resource Center.